Hello, welcome all. Here we are going to discuss Handshake Protocol in Secure Socket Layer SSL, and after that we are also going to discuss Transport Layer Security. In the previous section, we have seen what is web security. In that web security, we have seen the Secure Socket Layer SSL. The SSL can be implemented by using four protocols stack, which includes SSL Handshake Protocol, SSL Change Cypherspec Protocol, SSL Alert Protocol, and SSL Record Protocol. Here we are going to discuss SSL Handshake Protocol. Before going to that, we have seen what is mean by connection and what is mean by section. And also we have seen the SSL record protocol. That is where the data will be considered, where the data will be compressed, and after the compression, the calculation of MAC, appending the MAC, and after appending the MAC, applying the encryption algorithms, and after that, appending the SSL record header. Now let us see what is mean by handshake protocol. The most complex part of SSL is handshake protocol. This protocol allows the server and client to authenticate each other and to negotiate an encryption and MAC algorithm and cryptographic key to be used to protect the data sent in SSL record. The handshake protocol is used before any application data is transmitted. The handshake protocol consists of series of messages exchanged by client and server, which means handshake protocol sits on application layer and that is dealing with application connection and data security. The main purpose of handshake protocol is to establish the session, and the session will be generated by handshake protocol. Handshake protocol can be represented by using these three fields: type, that is a 1 byte, length of 3 bytes, content less than or equal to 0 bytes. Type here represent higher layer protocol, where length represents the length of the message and content represent the parameters associated with it. Before going to the working of handshake protocol, let us see some terms associated with it. The first one is session ID. It is a variable length session identifier. A non-zero value indicates that the client wishes to update the parameters of an existing connection or to create a new connection on the session. A zero value indicates that the client wishes to establish a new connection on a new session. Next one is cipher suite. This is a list that contains combination of cryptographic algorithms supported by the client in decreasing order of preference. Each element of the list or each cipher suite defines both the key exchange algorithm and cipherspec. Next one is compression method. This is the list of the compression methods that the client support. Now let us see what are the types of the messages involved in the handshake protocol and the parameters associated with it. The first one is hello request. This is client hello, server hello, certificate, server key exchange, certificate request, server done, certificate verify, client key exchange. And the last one is finisher. Here each message has parameters associated with it. In this protocol, the length of the particular message will be in the second field. That is, the length will be in the second field and the parameter associated with it is in the third field, that is content field. Now, let us see the working of handshake protocol and the messages involved in the different phases to securely exchange the data. Here we have a client and a server. In the first phase, the client will send a client hello message that includes the information such as SSL or TSL version, session ID, cipher suite, and compression methods that is supported by the client. Then, as a reply, the server will send a server hello message that contains cryptographic algorithm chosen by the server from the list provided by the client and then the session ID. And server also sends the server digital certificate and public key. After getting the server and client hello, the second phase starts. Now, in the second phase, the server will send a certificate to the client and also server key exchange and then requesting the certificate of the client by sending a message certificate request. Then the server hello done. So until the client receives the message server hello done, the client should wait to start the communication. Now the second phase is completed. The third phase will be started by the client. As a reply, the client will send the certificate message, client key exchange message, and also the certificate verify. That means in phase 3, the client will send the certificate and verifies the certificate. After the phase 3, the certificate verification of the client is done on the server side, and now the phase 4 starts. In phase 4, the client will send a change cipherspec message and also finish it message. And on the server side, The server will send a change cipherspec message and finisher message. So, after the completion of all these phases, the client is authenticated by the server and server is authenticated by the client. And this is done by mainly exchanging the certificate and key exchanges. So, by this process, handshake protocol is done. In short, in phase 1, the client communicates with the server by sending a client hello and server responds with the server hello. In phase 2 and 3, the server is authenticated by the client and client gets authenticated by the server. The following these phases are shows the authentication process. Now, both the client and server stops the process by sending a finished message. Now, the client and server can communicate with each other by sending the message or data securely. That is, once this handshake protocol is done, the server and client can now exchange messages that are symmetrically encrypted with a shared secret key. Our next topic is transport layer security. TLS is an ILTF standard initiative whose goal is to produce an internet standard version of SSL. Transport layer securities TLS are designed to provide security at transport layer. TLS was derived from a security protocol called Secure Socket Layer SSL. TLS ensures that no third party may eavesdrop or tampers with any message. There are several benefits of TLS, which includes encryption, interoperability, algorithm flexibility, ease of deployment, ease of use. While the purpose of SSL and TLS are very similar, these communication protocols are distinct in how they operate. This changes the developed over time as SSL moved through the various versions before it was succeeded by TLS. In this section, we highlight the differences. As we know, works similar in both SSL and TLS. SSL handshake is complex and slow, where a TLS handshake has a fewer steps and a faster connection. Now let us see some other key differences of SSL and TLS. SSL means secure socket layer, where TLS means transport layer security. Then version history. SSL is now replaced with TLS and SSL is moved through versions 1.0, 2.0 and 3.0. Where TLS is upgraded version of SSL. TLS has moved through version 1.0, 1.1, 1.2 and 1.3. Then activity. Every SSL version is now updated. TLS version 1.2 and 1.3 are actively used. Then alert messages. SSL has only two types of alert messages. Alert messages are unencrypted. TLS alert messages are encrypted and more diverse. Next, message authentication. SSL uses MAX where TLS uses HMAX. Next one is CipherSuite. SSL support older algorithms with known security vulnerabilities where TLS uses advanced encryption algorithms. That's all about this topic. Thanks for listening.